Hey everybody, welcome back to the channel. This is Nick, and if you're here for the first time today, um, this channel is a place where I talk about building an IT career, DevOps, different technologies, open source, things along that lines. And today what I wanted to do is talk about DNS over HTTPS/TLS. There's basically two different ways to go implement this. And um, the idea that I'm a little bit suspicious of it, and I feel like I'm missing something. And I thought this would be a good opportunity to model the kind of behavior that I think people who sometimes are a little bit newer feel a little bit afraid to put out there, right? So I think there's a distinct possibility that DNS over HTTPS is a very good thing, and I am misunderstanding it, and I am not seeing the major benefits. It's also possible that my suspicions are grounded and that there is some issues with it. So a lot of times when people are a little bit newer to an IT career, they are a little bit insecure. Maybe they're a little bit afraid to show that they don't know things because they're worried that that's going to be viewed in a negative light. It's going to reflect poorly on them. It might have, some issues in terms of their ability to advance, things along those lines. And my take on it, after having worked in tech for over 20 years, is no one knows everything. Everybody misses something. You forget stuff, and the best thing that you can do if you don't know something is be upfront about it and try to solicit opinions from other people and or do additional research. So let's talk about DNS over HTTPS. So let me switch over to a different view here so we can go ahead and take a look at this. There we go. So DNS over HTTPS is a pretty simple idea, right? So my understanding of the reason why the browsers, which is where you're basically seeing this right now, is that the browsers are the ones who are sort of pushing this as a tool, as a way to go ahead and configure things, is that DNS is plain text by default, right? So there's no encryption on plain text. So it's very easy for somebody to intercept that traffic and see where it's going. And in fact, they don't even need to intercept it. I think the main concern is ISPs, right? So your internet service provider. So what would happen is we would have you on your PC, and you want to go to, some website. .com, right? So some website.com has an IP address. Let's say it's 1.2.3.4, right? So you want to go to 1.2.3.4 colon 443, hopefully, right? So 443 is SSL or HTTPS, and we want to go ahead and browse this website. And the idea is that this connection, right, is going to be typically these days encrypted, right? So the idea is that if someone were to intercept this traffic because they were a router in between you and this website, they wouldn't have any visibility in terms of what you were doing, right? And that's a good thing, right? We want that. Privacy is beneficial, right? However, in order to go figure out that 1.2.3.4 is the IP address that is serving up content for some website.com, we need to talk to DNS. And generally, that's going to be a DNS server from your ISP, right? So, in the US, this could be, Comcast or, a bunch of other companies that provide, right, internet service for home and businesses, right? You may or may not, in your environment, have a DNS server, right? And oftentimes this will be on your router, but this then points to your DNS server. So what happens is before you actually go to somewebsite.com, you do a query to your DNS server that says what is the address for some website.com. And it basically goes, to the root, com DNS server. It finds out what the DNS servers are for some website.com's domain. It then asks them what IP address it should go to for some website. It gets 1.2.3.4 returned, and then you can then go initiate that encrypted connection to some website.com, right? And all is well as in the world, and all is good. Now, the issue and the concern is your ISP now knows that you are intending to talk to some website.com. And I think probably the most likely issue that people have with this, the sort of the least concerning negative thing that can be done, is that they will do basically the same thing that a lot of companies do in this day and age, which is sell user data, right? So let's say instead of some website.com, this was, newparent.com, right? And they have all sorts of information that a new parent might want to look at before they had their first kid, right? So it talks about, sleep schedules and what to, feed your first kid and all this kind of stuff. And your ISP says, right, I can make some money off of this because now I can go sell the information that the person who is coming from this IP address, your machine, which they know who that is, right? They can go sell that to advertisers who have, products that cater to new parents. So diaper companies, people who make formula, all that kind of stuff, right? So the idea is that this is not ideal, right? And there's some things that you can do, right? You can not take the default configuration, and you can go set up your DNS server, and I think that's probably a good way to go do it. But a lot of people are concerned that even if you don't use their default ISP, your ISP would have a DNS proxy, right? And the argument there is this would allow them to save network bandwidth and reduce the number of DNS lookups. To my mind, that would be intercepting somebody's traffic. And I haven't looked into the legalese of this, but I think that, it would be very likely somebody like the EFF could probably bring a lawsuit saying that this was hacking, illegally intercepting traffic that was not intended for them if this was sent to a different DNS server. But that's neither here nor there. The concern basically is, to my understanding, that this ISP knows who you're talking to. Whatever DNS server you're using knows who you're talking to. And then they can go, monetize that information, or, they might do something more nefarious with it, right? So let's say, for example, you were in a country with a government that had overreach, right? They could go look for, who went to, this website, right? If they were trying to go track down dissidents or whatever it was, right? So there's definitely some concerns, and there is the idea that this is potentially a bit of a hole where your ISP is leaking information about you potentially, right? So to my mind, I think that the right way to solve this problem is to make sure there's robust laws around what your ISP can do with this information. I think that your ISP should be prohibited from monetizing DNS, right? Because this is a core infrastructure service, right? So the idea is your browsers now have the option to go have it be configured to do DNS over HTTP or HTTPS, I should say. And the idea is instead of having this section where you go talk to your ISP's DNS, what's going to happen is you are now going to go and talk to a specific IP address. So generally, this is going to be one of two different IP addresses. This is going to be 1.1.1.1, or this is going to be 8.8.8.8. 1.1.1.1 is run by a company that does edge caching called Cloudflare. And 8.8.8.8 is run by Google. And they're both public DNS services. And the idea is that this traffic will now be encrypted, and it will bypass your ISP's ability to go see that. So your ISP will no longer be able to go see any lookups that are happening in the browser, and they will not know that you're going to, newparent.com, because that's going to be resolved internally, and then we can go ahead and connect to newparent.com. And the idea is that seems good, and it seems like, okay, well, we've at least sort of removed the ability of our ISP to track what's going on and see what we're doing. But you could argue that we've just moved this over to Cloudflare and Google. And one thing that you might say is that you trust Cloudflare or Google more. I think one of my concerns is this is much more centralized, right? So, we have a woeful lack of competition in the ISP space when it comes to the United States. This may vary throughout the world, wherever you are, might be different. But there's not a lot of ISPs, but there's definitely a decent number of them, right? So you have big providers, and they own most of the market, but there still are a number of smaller providers, and people can start their own ISP if they wanted to. There's community-run ISPs and things like that. So these do exist. So the idea is that there'd be a lot of them, right? And let's say we were looking more towards the idea of government overreach, where they were looking for dissidents, or they were looking for trying to figure out who maybe the not politicians, but maybe, well, it could be politicians, right? So it could be looking at other politicians, right? So let's say that this is trying to go figure out who went to a political party's website, right? So politicians, activists, people like that could be involved in it. Well, in that country, they could go to Cloudflare and Google directly, and they could subpoena that information. And because that's centralized, that's one single point, right? So I would argue that it makes it significantly easier for that type of overreach. Also, Google is pretty open about being a company that does advertising, right? They're trying to monetize your content the same way that people are worried about an ISP doing it. So I'm not sure really what the huge benefit is there, right? So this is kind of where it comes to the idea that I'm a little bit suspicious of this. I don't really know how I feel about this. And furthermore, if I go jump over to a virtual machine over here, I've got just the DNS over HTTP stuff in a browser here. This is just the Wikipedia page. So if you want to read more about it, you can go do that. And if you can look at the DNS over TLS, which is more or less the same thing, same idea. You can go look those up. They have documentation on Wikipedia that's pretty decent and very straightforward. But if I jump over here, where I've got a couple terminals already set up, and hopefully you can see this. Let me make this a little bit bigger. Let me do the same thing over here. Same thing over here. All right. So what I'm going to go do is I'm going to go use Netcat. Right. So Netcat, if you're not familiar with it, it's a very, very minimal program that basically opens up a socket on a port. Right. So I'm just going to do this on localhost. So I'm going to go say netcat-l to listen on 127.0.0.1, which is localhost on port 8000. Right. So what I'm next going to go ahead and do is I'm going to go over here, and I'm going to go ahead and run TCP dump. And I'm going to do this as the sudo, so as the root user. I'm going to do a TCP dump on LO0, which is my local host address. I'm going to have it quiet so we don't have a bunch of extraneous kind of stuff. And I'm going to do a -x to go ahead and dump out the hex as well as the ASCII information that one would see in the actual raw packets, right? So go pump in my super secure password there. And then what I'm going to go do is I'm going to go use the links program, which is just a text command line web browser to mimic the idea of going to this page in a browser. Now, this is not HTTPS. This is just raw. But the idea is that we're looking at packets with TCP dump, right? So if I go ahead and do an up arrow here, do links HTTP 127.0.0.1:8000. In fact, I can go change this to HTTPS. I don't think it'll actually make very much of a difference for this demo, right? So I'm going to go ahead and hit return here. You can see that we get gobbledygook over here that comes up, right? But what we can definitely see over here in our TCP dump is that we have the IP address of localhost.8000, right? Communicating with localhost 2230, right? And the idea is that 20.230 is where this traffic is coming from. If we scroll up, you can go see the initial packet initialization, right? So this is the packet, initially opening up. This is like the SYN that's going to go through the SYN ACFIN kind of process that you would see with TCP. So we're going to go connect there. You can see the session number as it kind of goes through, and you can see the information that was transmitted. Now, this is basically what your ISP's router would see. And what you clearly can see here is that they have the IP address that you're going to, and they have the IP that it was coming from. So if the goal is to cut your ISP out of this picture and to make it so they don't know who you're talking to, and the idea that you're going to have more security from this, I don't see it. They still have that information. The only additional thing that we're doing is we're making sure that Cloudflare and Google are going to get that traffic as well. So I'm a little bit suspicious of it. And mainly I'm making this video to bring this up as a potential concern for anybody who is, privacy conscious, but also to solicit feedback to see, what do you guys think of this? Is there something I'm missing? Because I feel like there's likely something I'm missing. I think Firefox and the Mozilla Foundation are generally pretty good actors when it comes to things like privacy. So my inclination is that they are probably doing this for a good reason. Now, it could be that this is part of some kind of partnership agreement with a company like Cloudflare or Google in order to solicit funding for the foundation, which is not something I would be against. I would just want to make sure that they would be very upfront about that. So I'm a little bit concerned about this. It's not something I've seen discussed a ton elsewhere. So what do you guys think? Do you think that DNS over HTTPS is a good thing? Do you think that there is a better way to do this? Maybe some kind of multi-layer approach where your initial DNS request goes through something like Tor, which I think I've seen discussed as a potential solution to make DNS over HTTPS more secure. I still think that ultimately, if your ISP has the routers that you are connected to, they are going to know who you're talking to. They know what IP address you're communicating with. And it's not a huge amount of overhead for them to do that. They don't need to go keep track of every single packet. They just need to go ahead and keep track of the SYNs, right? The SYN is the initial setup packet, right, that opens the initial connection. So if you just go track those, you can see every single website that somebody is talking to. So there's not a huge amount of benefit to it that I can see. I think that at some fundamental level, the internet is public, and we can do things to encrypt data that's going over the internet. But in terms of trying to hide who is talking to who, without things like onion routing, which most people don't want to go do because of the immense amount of overhead and additional latency that you get from something like onion routing or Tor. Um, the people that you talk to more or less are public. Now they're hopefully public to a small group of people, basically your ISP, but I don't see a huge amount of benefit to this. So let me know what you think. Right, I would love to hear what you guys think in the comments, and I appreciate any feedback that you have. This is presented with humility. I'm not saying that I'm an expert in this topic, but my initial sort of first glance, kind of mulling over of this, seems like there's something weird here. I don't know why this is beneficial to me to do it. I think that I would rather potentially have Time Warner look at my packets compared to having everybody consolidate in something like Cloudflare, especially if I was in a country that was a little bit more onerous when it comes to privacy restrictions. I'm lucky enough to be in the U.S. and hey, we got problems. We can definitely improve things from a privacy standpoint. We don't exactly have a clean nose, but there's a lot of countries that are pretty bad with this stuff, and these are publicly traded companies. So if they get a subpoena from the federal government in, let's say, Russia, or some other country where they don't necessarily have the best track record for dealing with rival political groups and things like that, I'd be very concerned about that. I might be more comfortable having my ISP have that information, because it would be more work for governments to sort of consolidate all that. So anyway, just some initial kind of first thoughts on it. Let me know what you think. And hopefully you enjoyed the video. If you did, feel free to subscribe, leave a comment, on the topic is always appreciated. There's a Patreon if you guys feel so inclined to support the show. But also there is a mirror of this information. Let me go pull it up over here on the on Library or Odyssey. So you can go to Odyssey. It's actually, I think I have Odyssey.com here. This should be Odyssey.tv, or actually Odyssey.tv here. This should be Odyssey.com. That's wrong. Yeah, so it's Odyssey.com/@NickTrains. You can go ahead and find my content over there as well. Nothing against YouTube. YouTube is great. They're a fantastic platform. I love the fact that they make things very easily to discover. But Library is a distributed protocol that has lots of different interfaces with it. I find it's to be nearly as good as YouTube for watching content. So try to check the show out there, and let me know if you are watching it on Library or Odyssey, because I'd love to know how many people are moving over. So anyway, have a great day. Take care of yourselves, and I'll see you guys in the next video.